Hi, I'm Daz Greenwood, research scientist here at the MIT Media Lab, and I run law.MIT.edu, where we research computation and law. And today we did a research update to the Human Dynamics group, and here's a little preview of what we did. With me is Mark Oblad, who demoed ValQ for creating legal entities and electronic transactions, and also Dan Buckner of Microsoft demoed their approach to blockchain-enabled identity and personal data sharing, all as part of our open source automated loan fund, which itself is part of trying to create a fully digital credit union. It's data-driven. So, Mark, do you want to introduce yourself and just show us a screen of what you demoed?
Yeah, great, thanks. I'm Mark Oblad. I'm a corporate lawyer, coder. I spend almost all of my time writing code. But talking about automated legal entity, we're going to jump right in. I'm here in valq.co. And what we're going to do is we're going to create a company. This is as automated as we can make it. Part of what it means to make a company is to create the paper that a Secretary of State, in this case Delaware, expects to see. And so a lot of that can be automated, but it also involves creating stuff like Microsoft Word documents. So let's create a company now. This company here, let's name it. We're going to call this Sunshine. Okay, and go ahead and submit this. Well, there's a few steps in here. It's really just data entry. We won't go through all of them. I'll just do this first one. Add myself. I'm in New York. And then what we're going to do is we're going to just jump over to another one that I put together already this morning. So let's go to this one called ValQ MIT Human Dynamics Labs Inc. Okay, and we're going to jump to the step where we can sign a document. On this step here, what you can see is the information about this incorporation has been merged into a document, very similar to what we started off in the other. And you can see the PDF on the page. There's some other data. There's the data itself. There's a red line against the template, and then we can sign it. So let's remove this signature. We can record a new one. Write my name. Now there's a whole bunch of data that's being created right now. Let me go back to that step, and we'll look at it. Part of the data around is that there's this header language. We can hash that language so we can know what was there when it was being signed, what it told us we were signing. There's the PDF version of the document itself. There's the different versions of the data. All of those pieces can be hashed and recorded. Let's look at some of those hashes. If we look at this signature, it's going to give us the hashes of the document. Here's the SHA-256 of that document, the docx version of it. And then you can see the signature itself, some of the information about the timestamps. You can see the IP address. You can see the user agent. In any case, there's a whole bunch of data that we're creating around it, and we're doing it in a format where we can record and reuse that data. Okay, we're not going to finish this one, but what happens from here is then you pay your Delaware fees, you choose your registered agent, and the document is transmitted to Delaware, and you get a legal entity. Now that's one transaction for a company, but there's a bunch of other transactions that companies do over their lifetime. Some of them are standardized to an extent where you can create easy tools like this. Others need to be a little bit more ad hoc. So what we've done to deal with those ad hoc transactions and to try to keep the data perspective and the automation perspective is created a very simple scripting language. So now we have a legal entity, and we need to hire somebody. So hire somebody, we're going to go over and get an offer letter. So I'm going to open this document right now in Word. Let me make sure that we're sharing appropriately. Share again. Let me do my entire screen, so you should be able to see. I believe you can see this now. Okay, so this is just a Word document. It's an offer letter.
And actually, you're not screen sharing right now.
Oh, not screen. Okay, that's good. Thank you for the. Okay. And
incidentally, one of the high points at the demo today was the integration with Word for legal documents is terrific. That is, after all, the application that they work out of, that they're comfortable in for these contracts. So the ability to treat that as data and have integrations and workflows with it was a point that people liked. Oh, sorry, I was filling a little time while you got your screen share go. Back to you.
Okay, great. So this is the Microsoft Word document. What this is an offer letter. It's a simple at-will contract between an employee and a company. It says, hey, you're going to come and join us. Here's your role. Here's your salary. Maybe you have benefits. It might also list stock options, and you might vest in those stock options. But you can see, again, that this is just a Word document, but there is some scripting in here. It's just text. You can see these things. Everything that begins with V field is a script tag, and those will, writing it this way makes it so a computer can read those and identify those as script tags and create all the workflow around a document like this, like a form that you can fill out, the ability to merge it, and the ability to collect that data. So I'm going to close this document, and we'll take it, go back to the application, take that same Word document you saw, and drop it on the application. We've got a parser now that's going to read the scripting in there and create the form. You'll see that momentarily here. Come on. So after some validations have run, all these tags were created here. Created this form that you could fill out. If we were to go to another page and fill out this form, we could get a Microsoft Word document back, all the scripting removed, and the data now in it. Okay. Now, here's the structure of those tags as well. You can see the nesting relationship of it. And again, the original document. One thing I might show in here is that with the scripting, nested fields, very calculable. It's very easy to write the code. It's not easy to write the code, but the code can easily figure out which fields need to be hidden and which need to be shown. So you can see that here when I click yes on this, the nested fields appear. All right, so we're going to skip some of the steps to putting this document together as a transaction, including mapping the data to a data room. What I've done here is I've gone through and I've filled out the form, and the document has been merged together, and it's a pretty good looking document. This is the PDF version. And I'm on a page where I can sign it. So I'm going to hit the sign. We could record a new signature, or we can just hit one of these signatures that we already have recorded. I'm going to hit that signature. Now I'm going to go back over to this completed transaction and reload the page. Now that we've signed that document, I'm going to close that transaction. And now we have the possibility of pushing this transaction to the blockchain. So let me hit this. As I showed you before, every time you deal with a document, it's easy to run various digests of it. Here are the SHA-256. This is the number that's generated by running the document through the algorithm. And if any change were to be made in the document whatsoever, this number would change. So this is the number that we would document in this exact format that existed at this point in time. So to push it in the blockchain, we'll hit this, and we're going to push this in real time. What happens now is that this hash is going to another service, in this case Tyrion, and Tyrion is going to collect these hashes from its users over 10 minutes, construct them into a Merkle tree, and then record the root of the Merkle tree in the blockchain in a piece of a transaction called OP return. It takes a few minutes for this to register. You can see it hasn't happened yet. Let's run over to one that I did earlier today. So here's one that I did this morning. In this case, the SHA-256 was this number right here. And the API service, Tyrion, gave us back this write proof, which if you combine together with our original hash, you can calculate the Merkle root, and this is the number we want to see in the blockchain. So if I go over to another service, in this case, blockchain.info, and look up that transaction, and go down and look at the output scripts down here. Again, just to be clear, this is a separate service. This is actually viewing what's in the blockchain. I can see that that number matches. I just searched it on the page, and you see it found it because it's the same number. This page has been loaded earlier today. You can see earlier today was 20 confirmations. If I reload it now, I bet it's going to be much more. It's 42 now. So now you've seen sort of a traditional transaction, what it looks like to put that in the blockchain. Given the data we have here, you could also go and reconstruct this this Merkle tree externally. Document, I could do that here. Download the original document, save it to my desktop, replace it, show it in a folder, get the pieces of it. The pieces were right here. So the write proof on the Merkle tree is right here. Go to a validation tool, add a write proof, put that in there. Now then, drag this document on. I know this is a few steps. We should hopefully get the same number. Okay, it looks like this is going to be the same number. It is. Okay, so it matches. The final thing I want to show. And I'm going to click on this and take you down to this section on vesting.
Oh, sorry, Mark. We lost your signal a little bit with the final thing I'm going to show is.
Okay, so yeah, the final thing I'm going to show is I'm going back into the offer letter that we had started in, and I'm going to look at a couple of the fields in here. So you can see if you decide that there's vesting in this transaction, you can say you can describe the initial percent that's vested. You can describe if there's a cliff, perhaps that's after 1 year of service to the company, 1 year's worth of the shares might vest. That might be something like 25% of them. And then after that, over a total of 4 years, the rest will vest. That is reducible to a nice formula. That also means that this piece of the contract, the bigger contract, could be put on a blockchain like Ethereum as a smart contract. And over time, you can tell what percentage of the shares are vested. And perhaps if you wanted to stop the vesting, you would record a second event on the blockchain, indicating that, for example, the employers know the company, the service is terminated, and thus vesting has stopped. All of that can be recorded and timestamped and be calculated as a smart contract. So that's the gist of what I've got here, Daza. Happy to answer any other questions, or if there's anything else you wanted to discuss, happy to jump in as well.
Thanks, Mark. That was really great. And I think people were excited about how you approach legal entity creation and contract and just basically transaction workflow, and that you're already expressing hashes. I should say expressing the documents as data and hashing that data regularly, makes it not certainly possible to put evidence on the blockchain as you showed we're doing, but also it just demonstrates that your information is computable. And that's huge for the Human Dynamics group here in the Media Lab, where it's fundamentally a data science group. And so I should take the opportunity to just show the slides that the that your demo is fundamentally part of, and it's part of a collaboration we're doing to prototype, eventually a federally chartered credit union. But initially on something, a bite that we could actually, chew would be an automated loan fund. So I've got here we go, the research slides here that demonstrate the overall, I'm going to call it like the workflow. Wait a second, where are we here? Sorry, where is my Hangout? Here we go. So let me screen share. Where's the screen? Come on. Boom. Okay, that is not what I want to share. There we go. So here is the, it's a little bit sluggish, but you can sort of see it here. This is the prototype automated loan fund workflow that is our target operating reference implementation that we're trying to code to. You'll see here, automated legal entity, Delaware Corp. You've demoed it. Enforceable contracts and transactions, you've demoed it under Uniform Electronic Transactions Act and Electronic Signatures and Global National Commerce Act, just under the basic, common law of contracts and basic state corporate law. I think this what you've demonstrated is over sufficient and even elegant. The idea of having publicly verifiable evidence recorded on a blockchain is also part of it, and I think you demonstrated that as well. So if you, I don't know, can't quite make out this diagram, but the right lane is blockchain. So we've got a signed contract for a loan, boom, on the blockchain. We might do acknowledgments of each individual payment, and at the end of the day, your loan is paid off in full. Got a discharge of debt, or possibly a default. So we're showing that, and now looking forward, this idea of like self-sourced valid identity and data is a part of the integration that is being actively worked on and provided. Oh, wait a minute, by Dan Buckner at Microsoft. So Mark, maybe you could let me know whether this screen share is showing the video in just 1 second.
Got a nice endless screen of screens within screens.
I know, it's mystical. Here we go. There. Okay, and let me know if you're getting this audio.
Great. Okay.
And so next up,
it's pretty faint, but I'm getting it.
Who's going to talk through integrating blockchain and the web for individual identity and personal data ownership. Dan?
Yep. Great. Awesome. So, I'd love to present our view at Microsoft of decentralized blockchain-based identity. Really, I think it's important to think of identity on the blockchain in the way that we're envisioning it anyway, not as just a replacement for what you think of as traditional identity in the world today, OAuth. Things that are really more about authentication than identity, even though OAuth and existing protocols do offer some preferences and data storage. They're federated, and they're more about logging you in socially and doing those sorts of auth traversals. So the system that we're building, obviously, it's going to do all of those things, and it does all those things, but it also it's beyond something as simple as auth. So really, it's sort of a foundation for a new class of apps and services. To establish a foundation, I think it's important to separate two things. One is identity from an identifier. So an identity is the actual data that makes you up. So it's all the things that people attest about you, self-attest about yourself, attributes, activities, how you relate to the world. So you saying my favorite color is green, and someone else saying, yes, you did graduate from this school. Those are all things that make up your identity. and that's the data piece. There's a lot of data that makes up you, whereas an identifier is really a shortcut to meaning of who you're talking about. So, when I say @Satoshi or www.microsoft.com, what I'm really doing is saying, here's a human-friendly way that I can refer to an identity, a thing in the world. And it's important to separate them because what they are and where they are rooted, blockchain versus off-chain is sort of the distinguishing factor. And so I'll talk about how blockchain applies to our system. Blockchain is interesting for identity because it solves really proof of ownership of these tokens. And in the Bitcoin system, the tokens are inferred to have value by the market, monetary value. But we are using that system through a partner named Blockstack, who I think has a really great reference implementation of name rooting, to hijack that system to embed transactions that normally would be no value with payloads that can register names. So if you think about every transaction on a blockchain as a check, no matter what you put in the line for how much the check is, you still get the same memo. So that memo line is just as big and just as much text in it, whether it's transferring 1 cent or $1 million. And what's interesting about that is, you can use that free form space any way you choose. So what Blockstack does is they take that check and they write in some code that essentially reserves a name. Let's say Dan.id or app.foo.app, and then also relates it to both keys that prove that you own or whoever possesses them owns that ID, and off-chain locations. So 3 really important things: registering a name, that's an identifier that's easy to relate to, who owns it by tying it to a pair of keys, and then where does it point. And this is a really important thing because under our concept, and we agree with Blockstack, that really the only thing to go on the blockchain is the identifiers. And once you have identifiers that are linked to keys and point off chain, you can do almost everything else by signing pieces of data with those keys. So this is what we see as the whole ecosystem, all the pieces in the blockchain identity system. The first one is the blockchain. It's actually a small part of the ecosystem, but very important. And it's used by the name registration and indexer to root names. So I might have bill.id has keys associated with it, and bill.id on the blockchain points at what we want to call an identity container or identity hub. And within these hubs are all the data, the identity that we talked about initially that make you up. So you saying that your favorite color is green, where you went to school, your school attesting to that, your driver's license, perhaps digitally signed by the government. That's where your identity data lives, in this encrypted container with an ACL that meters access to it. So you can, as a user, self-sovereignly own this container on your devices, in the cloud, and be able to meter access to that data so that, if maybe your friend has access to your songs, but it doesn't have access to some of your personal financial documents, whereas your wife or spouse or whatever might have access to everything. So that's what that's used for. And really important is that there's a standard REST API that all these containers, regardless of implementation, can use to communicate over, so that we have this interoperable world of identity data. Just to give you a quick example of how you would address a container. Every container, it doesn't matter what the URI is that it's located at, which the blockchain points to, they all respond over the same RESTful path interface. So in this case, you can see 3 examples at the top. If you were to use the schema.org, or wanted to use the schema.org schema, you could say, well-known identity, which is an RTF standard already, the ID that you want to address, and then saying that you're going to address data, and then just using the exact same structure that you would find in schema.org. So if you look at schema.org for phones, already described these schemas. We did this for a number of reasons. The biggest one is that we just wanted to be able to say, here's a known location for certain data and not have to argue about it. And that's, if you've ever been in the standards world, semantics and nomenclature and taxonomies are some of the most fought sort of battlegrounds. And really, we didn't want to, as Microsoft or any of the companies participating in this open source venture that we're trying to post one world, we just wanted to really give away the use, anyone that made sense maybe for an industry. So some industries like medical might use FHIR and HL7, not schema.org. And so that's fine. So you could imagine replacing schema.org here with FHIR, and then obviously the structure that made sense for that medical schema. And so below you see here is an example of like a payload. So if I had the ability to see Jane.id's playlists, I would make a request to this route signed with my identity's keys. And what the response would be is all the playlist type objects that come back. And so we think that this is a really pretty awesome way to democratize the transmission and evaluation and presentation of data. So with this example like playlists, you could write an open source client-side only app and be able to consume users' playlists and do the same sort of fidelity of playing those songs and validating access that any other organization like Spotify does. So what are really the pillars of this ecosystem? We already talked about one, the global mix of IDs. Next is hardware and software for storing the identity keys and all the UX aspects of things. That's never a problem. That is, you're always working for better solutions. Obviously, this system is based on non-cryptographic solutions, which means the key management problems there. We have some unique ideas on how to do that, and we have some partners that are bringing in form factors that help people make this real for them. And then another one is identity agents. So, like I said before, maybe your buddy has access to a certain part of your wife, or your husband has more access. And all of those agents are agents because they're agents of your identity. From Microsoft, maybe Cortana is one of your agents that has access to your calendar and driving updates and stuff like that. So it's always scoped to what the user wants to permit the agent to see. And then, of course, the identity containers that we discussed already. So really, with this foundation, you should really think of it as these. And whole idea of apps and services to be built on top of that. So anything.
Sorry, Mark, could you? We lost your. Dan, we lost your feed on the last sentence. Could you just repeat?
Okay, just repeat this. Okay, yeah. So I would look at this as a system of identifiers that are linked to containers of semantic data, all self-sovereign to the user, and really they're just the foundation on which you build a whole new set of apps and services. So you can see on this slide, there's quite a few, but anything from classified sales to IoT devices to property records can be done through the system. One thing I'd like to highlight is the difference between what's on-chain and what's off-chain. So on the left of this slide, you can see, this is a apartment rental example where Bill and Jane write up a contract. Right now, there's a lot of APIs. We can take a piece of data and hash it, and then put that hash in a blockchain. And that proves a couple of things. It proves like rough timing, that there was some document out there in the world that matches this hash, and it was entered into the record at this time. Doesn't prove who was attached to that document with any real certainty. It doesn't prove the actual document itself, because like you see below, you have to keep that source material off chain somewhere. So it really is just a rough timestamp. And then we move to possibly this other way of doing things, which I think is just more efficient and kind of better all the way around, where Bill and Jane, they register identities on a blockchain that are linked cryptographically through the keys that are tied to the identities, and they can sign really high fidelity metadata and that same rental agreement off chain together as one piece of data with timestamps and signatures and everything else. And then they still store it off chain just like they did before, but they can have precise timestamps that are atomic time. They can have signatures that validate who they are and the fact they signed at that exact time. And then they can produce that object at any time that's called into question what the agreement is about. So same system, the point here is that you don't flood the chain with these hashes, which are of limited value. So just to kind of drive home one example, it's more a consumer use case, We talked about, where data lives in the container. Now let's imagine like you're going on Craigslist, you want to sell your car, you generally go there and you enter data into a form. And that data is transferred to the database, put in Craigslist DB, and from there on, people who want to see your car have to go to Craigslist, the app. We think that there's maybe this new model where you as a person have your container and you put a semantic object like a car inside of an offers path, which schema.org has. It's under thing and tangibles offers. And then what happens is you could write an app, a crawler that has an app. Anyone really can, and they can scan all of these paths that people choose to publicly expose. For instance, offers is probably a path you choose to expose, and then form the same app view you might get with the Craigslist, but really none of the data had to be entered in Craigslist. It's solely owned by the institution. It kind of breaks down the concept of these walled gardens, and we think that that's pretty interesting for a whole new class of applications. So in closing. Really, the future we believe isn't just this Internet of Things like devices. It isn't like OpenID for people and websites with traditional DNS. Really, this system can become the substrate for all of those things and more. And with projections about how proliferated devices are, both IoT and connected devices, people, objects. We think this web can grow to be hundreds of times larger than the web today. And it's more efficient, right? Like right now, the web is based mostly on HTML, and you crawl it. You try and find this data meaning for what the entity is trying to express, but it's all inference. It's very difficult. So for data that an identity is really truly trying to express about themselves or what they're offering, we think that the structured, imperative, reliable data in these containers is a great way to go. And so that's basically it. So thanks for the time to present, and I hope you got a lot.
Wow, that was
Okay. Here we go. So let's get back to the Hangout here, and I will stop that screen share. That is kind of funny when it goes off into infinity, isn't it? So there you go. So, and it was good. So just to kind of bring the threads together here. Here we go. Whoa. Dan, Mark, are you seeing the?
Yeah, I see the swim lane chart.
Great. Okay, so that brings us. That really fills out the fourth bullet: self-sourced valid identity, and that is identity people are creating for themselves on public open blockchains, and the data store, permission-based personal data. And so here's some slides that we're backing. I think fundamentally what you showed, Mark, and I'll just skip across them. Here are Dan's slides, and they are all available at, I'll go to the last slide, law.MIT.edu, where I've just embedded them, and where I will embed the video that results from this Hangout on Air little update. The project that we're working on, the MIT part of it that brings these components together, is licensed under MIT license, and narrative materials are licensed under Creative Commons attribution license. Work out of GitHub for the most part on this project, and we have a Slack channel. If you're interested, come to law.MIT.edu /contact and give a shout. Again, I want to thank Dan Buckner, Mark Oblad, and not present Tommy Leander at the U.S. House, who's been just invaluable as a collaborator, and who'll be joining us also in January for the IAP, the Independent Activity Period course that we're putting together to really take a deeper look at these systems, these transactions, and what the legal basis and legal frameworks are for them, how lawyers can utilize and can assess and analyze transactions that are occurring with these tools. The legal analysis may be a little bit different, maybe easier using data analytics to do legal analysis in some cases. So we'll be putting together some standard terms for defining blockchain and defining some of the substance of transactions using these tools, and also learning how to use the tools as a way to create contracts, transactions, and then a full test with this loan entity. Doubtless we'll be doing some other things as well. I'll leave it to Tommy to talk about convening legislative and UITA and e-sign dialogue, which will continue from a roundtable that we worked on together, Mark, Dan, and I, Tommy, and Digital Chamber of Commerce, and others in the U.S. Capitol. And we're planning to do this IAP course free of charge at MIT. If you're a student, we'll have a course number, you can get your credit, and it will also be online. And we'd like to use the opportunity to test out this new curriculum and start to get some feedback on this method of doing professional education and continuing legal education. So with that, I want to thank you again, Dan Buckner, and thank you, Mark, very much, who's here in the Media Lab with me. And I look forward to seeing all of you online.